Okay, so we have two lessons that have been posted about the product rule and the quotient rule. Just going to double check that that works, and it does. So today we're going to talk a little bit about applications, applying what we've learned for the product rule and the power rule, not the quotient rule. The quotient rule is what I'm going to be teaching you on Friday. So the first test is only going to cover 3 rules. That doesn't mean for derivatives that there are only 3 rules. There are multiple rules, and the second test is going to be progressively harder than the first one because obviously the rules get more complicated. But for now, the 3 simplest rules, in my opinion, power rule, product rule, quotient rule. So when you say, Miss, what is going to be on the first test? Power rule, product rule, quotient rule. Okay? The first test is, and derivatives is actually my favorite topic in calculus. Limits are my least favorite topic. So if I didn't do well on my limits test when I was in grade 12 calculus and now I teach calculus, limits shouldn't define your opinion of calculus. You are not going to use limits for the rest of the course. You will use limits again in university, okay? It is something that is applicable to real life applications, and especially when you're going into engineering or you're an innovator, an inventor, and you have to create things with different parameters. But for the rest of the course, we're really going to focus on derivatives. So kind of take your experience with limits, leave it at the door, and we are going to progress. Moving forward, this is something that's going to be used in Module 2, Module 3, Module 4. It's going to keep coming up and up, back again, so we have to learn the rules correctly. Okay, so remember I told you that whenever you have a constant number by itself, there is no rule that you apply. Well, you're kind of applying the power rule, but there is no variable with a power. So we automatically know that the derivative of those terms will be 0. So can someone tell me which derivatives will be 0 for this particular question? I know for sure A, because that is a constant number. What else is going to be equal to 0? Chantal? D, definitely, root 7. And the last one is a little bit tricky because some people think pi is a variable, but pi is not a variable. Look at that big long number posted in every math classroom, in the math high school classroom in the world. Pi is actually a number. So the number pi multiplied by negative 7.1 will give you a constant number, and the derivative of all constant numbers are equal to 0. Okay, so now we are going to go one by one and apply the power rule. Now you should think of power rule when you see power rule on the test as easy marks. For me, that's easy marks. It's the easiest folder. And so we're going to apply step by step. I also want to go over proper notation. So when you see a function with y is equal to x, you don't want to put f prime of x. You want to state dy over dx. That is how we denote the derivative when we have the original function as y is equal to. Now, the power law states that I have to take my power and turn that in, bring that in as a coefficient. So it becomes like kind of the number part of our term. And I have to take my original variable with the original power, and I have to subtract 1 from that. So that turns into 1 times x to the power of 0. Well, we know anything to the power of 0 is equal to 1. So 1 times 1 is equal to 1. Okay, so I'm going to keep saying the same procedure. No matter how hard the equation is, you'll see that the power law remains the same. So dy over dx, when we have 1/4 x squared, well, I know originally I have the 1/4. But I need to take my highlighter, that x to the power of 2, and I want to bring it down as a coefficient. And I want to take my original x to the power of 2 and subtract 1 there. So that gives me 1/4. Oh, sorry. I should actually just multiply to simplify. So 1/4 times 2 is going to give me 1/2. And x to the power of 2 minus 1 gives me x. Once we fix this smartboard situation, you'll be able to see the colors better, which will help you see what part is applying the product, the power rule. I always get those P's mixed up. So for C, I have y is equal to -3 x to the power of 4. So dy over dx, okay, my -3 is already there. I'm going to take this x to the power of 4, bring it down as a coefficient, and then I have x to the power of 4 minus 1. So dy over dx is going to give me -12 x to the power of 3. Please feel free to stop me if you catch an error or if you're unsure of something that I am doing. Now, radicals tend to give students problems, but remember, as much as I feel for you guys because you did do MCR in a pandemic situation, we still are responsible for the building blocks from MCR because they provide the foundation for calculus. Unit 1 was radicals and powers, and even in grade 9, and I've taught some of you in grade 9, you did negative exponents, you did numbers with fractions as exponents. So these are concepts you really need to know. And if you do have problems remembering, my YouTube channel is there, not because it was fun for me to make, but because it helps students that have gaps in their knowledge review material. And there's videos all the way from grade 9, grade 10, and MCR, and MHF. So those of you who are taking MHF right now, you can use those videos to help you with your course, right? Or to clarify anything that you don't understand. Now, the first thing I'm going to do before I go to my derivative is I want to write this as a rational exponent. That means I know that the the power is my numerator, and the index over here is my denominator. That's because this is a fifth root, the rational or the fraction exponent is going to have 5 in the denominator. Now you can see these are a little bit more complicated to solve. So I have dy over dx is equal to, I'm going to bring this 3/5 to the front. Now this is the part where students make mistakes, so please pay attention to this. When I take my original x to the power of 3/5, you have to subtract 1. And even though I know you are in grade 12 calculus, the problem that all students have starting in grade 9 always has to do with fractions. And that comes down to maybe your elementary school experience. So before I go any further, I don't want to do this in my head because I want to make sure that I don't make any mistakes. So I'm going to have 3/5 x to the power of 3/5 minus 5/5. I want to change it to a common denominator to make sure I'm not going to make any mistakes. Now you'll notice that 5 over 5 is greater than 3 over 5. So right away, I know I'm going to have a fraction that is negative as my power. So dy over dx is going to be equal to 3 over 5 x to the power of negative 2 over 5. Now, if you don't know what to do next, you will still get heart marks on the test. That's the beauty of short answer and why I don't like multiple choice. As much as you guys like multiple choice, if a student makes a tiny little mistake, a negative mistake, they get 0 marks on the question. Whereas this student, I would give 3 marks on the question and maybe an additional 1 or 2 marks upon answer. So that partial marks is always better than no marks at all. And that's why I kind of detest multiple choice. Now, to convert this, so we do not have a power with a negative fractional exponent, I'm going to keep my 3 in the numerator. I'm going to keep my 5 in the denominator, but I'm essentially converting this portion to radical form. So I have my index and my numerator is the power. For some of you, that's going to be like, huh, what just happened there? I cannot teach you that in 5 minutes. That's something that you have to have a whole video on it in MCR, and you have to review those concepts because it's going to keep coming back over and over again in the course. Powers that are rational exponents and how to convert them into radicals. Rational and radical are not the same thing. Rational means fractional form, fraction form, whereas radical is like, you can't say square root because square root has an index of 2. We have to talk about cubic root, power of 4, power of 5. Now, a student asked, I forget who asked an interesting question the other day. Well, Miss, you know, x to the power of 3, like I know that is even hard for factory. There's a reason why MHF and MCV are co-requisite, because as we move further into the course, you're going to be responsible for dealing with polynomial equations all the way up to x to the power of 9, sometimes x to the power of 12, x to the power of 15. Not necessarily all the time to factor them, but you will be applying derivative rules to them. We're going to be dealing with equations with large powers because the prerequisites that I'm handing you to get into engineering, to get into life sciences, when you're looking at a lab and dissecting the atoms or electrons or what's happening, you're dealing with numbers with very high powers, okay? So it is a concept you do need to know in senior math. Okay, is everyone with me here? You kind of understand what I'm doing? Perfect. Okay, let's solve a much simpler question, but I still want to rewrite this question in a different form. I don't want to keep it with a numerator and denominator. I want the numerator as my constant term, and I'm going to rewrite my denominator as x to the power of -1. When I do that, okay, so I'm going to keep my 5 there, -1. I want to bring that down to multiply. And then I have x to the power of -1. I have to remember to subtract 1 from that. So that's going to give me y is equal to -5. Yeah. Oh, yes, sorry. Thank you for reminding me. See, I need reminders as well. Thank you very much, Chantal. So now I have x to the power of -2. I cannot keep my answer like that. I have to convert any power that has a fraction or has a negative number. I need to convert it. Yes. Okay, very good question. Remember, this -1 has to come down and be a coefficient, has to be multiplied by the original 5. That's how that becomes a negative 5.
No, why is it 5 times x? That's the first step.
5 times.
X to the power of negative. But isn't it 5 divided by x over 1?
No, no, no. So remember, that this is like 5. 5 over x is times 5 times 1 over x, right? 1 over x, how we write that is x to the power of negative 1. You understand? So this is 5 times x to the power of negative 1. But excellent question. I love when you guys try to clarify things. That makes my job a lot easier. So yes, when you are unsure, try to write it separately so you can see it better. That's a very good point. So my final answer here would be dy over dx is equal to negative 5. Now, negative 5x to the power of negative 2 is the same as negative 5 times 1 over x squared. So this would be negative 5 over x to the power of positive 2. So today I might only have time to just do the power rule, and I might post another lesson with the product rule example. Yeah.
So just to clarify,
Yeah.
since the first step, it's technically like, obviously you flipped it, but that's technically 5 times 1